One, you have asymptotes of your new graph. Number two is you have a point of discontinuity in your new graph. And number three is you have both asymptotes and discontinuity. And the scenarios work out based on how many of your factored expressions cancel out. So let's look at page 306. So I've got x squared minus 3x minus 4. So I've got to factor it. Now again, the whole point of this is, can you do this without a calculator? Can you graph this without a calculator? Alright, that's the whole point of this. So it says, sketch the following graph. So I need to sketch that. So what is it, the first thing that I notice with this? I have a common factor, one on top and one on the bottom, which then means what? I have a point of discontinuity. And that point of discontinuity is at x can't equal 4, right? So now that I've factored this, I'm left with the graph of x plus 1, which go to 0 and 1, up 1, right 1. There it is. Now, the only thing I did not tell you yesterday is when you do your point of discontinuity, you actually got to find out what the coordinate value is of it. So I go to where x equals 4. So let's say it's somewhere right there. I put a dot on it. So that is at x equals 4. 1, 2, 3, 4. So that's at x equals 4. So let's find out what it is. So to find out what that actual coordinate is, I put it back into the equation for f of 4. So that gives me 4 plus 1. So that point is actually at 4 and 5. So it's not very tough, but I didn't do that yesterday. I didn't show you and tell you that you need to actually get the y coordinate, y part of the coordinate. Okay? Easy enough. All right? Questions? Oh, good. Let's go to the next one. Okay, the next one. Compare the following graphs. X squared plus 4x plus 3 over x plus 1. X squared minus 4x plus 3 over x plus 1. Okay, so let's factor them fully. That's the first thing you've got to do. So let's factor that first one. What does it factor to?
X plus 3, x plus 1.
Thank you. X plus 3, x plus 1. And all of that is over x plus 1. Right? So what do we notice? Yeah, point of discontinuity. And it's at what? X equals, or x can't equal -1, right? Correct?
Yeah.
Plug that in. So the coordinate will be -1 and 2. Just by plugging it into the equation. So I graph this guy. Same thing. 1, 2, 3 up to here. And then I go up 1, right 1. I got that. And then my point of discontinuity is right there. So put an open dot. So far so good, right? Pretty straightforward. Okay, let's look at the next equation. When you factor the next equation, what does it factor to?
X minus 3, x minus 1.
X minus 3, x minus 1. And what's on the bottom?
X plus 1.
X plus 1. Okay. Any points of discontinuity? No? No factors on the top or the bottom, right? Okay. So the difference between the two, and that's all they're asking you for, the difference between the two, they're going to tell you to do it. It says with the help of technology you should graph this. I'm not going to. But the difference between the two is this one is going to have asymptotes. Where's your asymptote going to occur at? X equals -1, right? That's where it's going to occur at right there. So you're going to have that as an asymptote. You're not going to have a point of discontinuity, and you have to graph it using technology in that case. But I don't really care to. Okay? So again, this whole thing is designed, can you do this except for that part of the question, can you do it without technology? All right, so let's look at 308. F of x is equal to, factor the top, please. Factor the top,
X plus 4, x minus 2.
factor the bottom,
X plus 4, x plus 1.
okay? What do we notice? We for sure have a point of discontinuity, so it occurs right there, and that is at -4, and put that in here. -4, that makes that -6 over -3. -6 over -3 is 2. So my point of discontinuity. So I'm going to just put this POD is there.
Yes.
But now I need to graph this. Okay, so what do I have to do? Remember what we did yesterday?
Plus 1 and then minus 1.
Plus 1 and then minus 1. So that gives me x plus 1 over x plus 1. And then I've got -3 over x plus 1. Just like that, right? So my graph is -3 over x plus 1, add 1. Okay. So I need to graph that. What's my a value? -3. My b is the 1. C value? -1. And my d value is 1. Okay, so I have asymptotes. Where's my horizontal asymptote? Plus 1. Y equals plus 1. Where's my vertical one? X equals -1. So those are my two asymptotes. All right, so to graph this guy, let's move my asymptotes first. That's the easiest thing to do. So, no, let's not. We should start always like this. My bad. Sorry. Sketch the original and change these coordinates based on my equation. So what does the -3 do? What are the two ways we can look at it? You can reflect it or flip it, right? And times your y's by 3, right? Or just times your y's by -3. So what am I looking at then? This coordinate here, which is -1, -1 is going to become what? -1 plus 3, right? Up here. This point right here becomes what? What is it? 1 and -3, so somewhere down here, like that. So far so good. My asymptotes shift left 1 and up 1 to right there. I'm actually done.
But you have to move your.
I don't have, oh, sorry, yeah, you're right, my bad. Thank you. I lied. Okay, now I gotta move these two coordinates. So this coordinate has to go left 1 and up 1, so what does that take it to?
0, -1,
Left 1,
0,
0, -2, so that's right here. Let's go with this color, right here. So it looks like this. Okay, and this guy, left 1 and up 1 is -2 and 4. So that becomes -2 and 4. What did I say this guy was? 0, -2, right? So my line green is my graph. So that's without technology to do it that way. Is there any part of that, I moved through it quickly, is there any part of that that causes you problems? There's only 3 key points. Where those asymptotes cross, oh, we forgot one thing, what did we forget? Point of discontinuity at -4 and 2. Okay, so we'd have to draw that in and somewhere like right there. There's the full graph. So today I showed you 3 graphs one with point of discontinuity, one with asymptotes, and one with both. Alright? If you can do this well, you'll have no problem. And again, I told you this at the start of the year, after that first unit. If you look back at the first unit right now, it'll be a breeze for you. Alright? Because we have done this in every single unit since, haven't we? We've done trig, we've done logs, we've done exponential, we've done polynomials, we've done rationals, we've done it all. Square roots, it's all A, B, C, D. Okay? Any questions about this? And then 9.3. 9.3 is just connecting, taking two graphs and connecting them. Did you guys start 9.3? Yeah? You haven't done? Okay, so let's just have a look at the first example. I'm going to do it algebraically, but it's also designed for you to do it graphically with technology. Now, I just happen to be doing this with the grade 11s right now. So, if you're asked to do this graphically, just graph it and find your intersection points. Graph the left side, graph the right side, find your intersection points. Now, we've done that in grade 10 and 11 with lines. Now you're doing it with different shapes. So you could have as many, if you look at a graph, you know, if you look at the graphs that we're doing right now, these guys, I could have 2 points, right? I could have no points of intersection. It could go right between them. So there are those possibilities. All right, so algebraically, this you'll have forgotten probably, I'm guessing, from last year. So I'm going to go through it. I have a polynomial expression. It's all factored and everything. I need to get rid of the denominator. So what's the common denominator here? 6x. So I'm going to times everything by 6x. Okay, x is canceled, leaves me with 18 equals 6x plus 6 is cancel, x squared minus 13x. Get everything to the same side. 0 is equal to x squared minus 7x minus 18.
Should just be 6x.
6x. Excuse me. 6x subtract 13x.
Yeah.
You good? So what are my two solutions?
Maybe at 9 plus 2.
So x is equal to 9 and negative 2. Those are the x values where they intersect. I need to find the y value where they intersect. So you can just stick it into one of these equations here, on either the left side or the right side to do it. Okay, and get it? So my first coordinate will be 9 and 3. Sorry, that's not right. 9 and 1/3. My second coordinate is negative 2 and negative 3 over 2. Those would be your two coordinates. And you can use either side to get that. Alright? That's algebraically. Graphing. Graph y equals 3 over x. Graph that side and use your calculator to find out the intersection point. We don't do a lot of this on the exam. Because this is basically, if you're doing it algebraically, it's grade 11 work. Because you do all this in grade 11. Okay. All right. Any questions? All right. Then I'll take today to finish up. We want to be 39192, and we at least started on 9th Street for Tuesday. We do have a test Monday on 7 and 8, so I would look at that as well today.